Good afternoon. This is Unit 10, Day 10. We're going to do a review of our log properties, and we're going to review some of the different kinds of problems you're going to be expected to do with log properties, as well as using your calculator to calculate logs with different bases. So what I'd like you to do is pause this video, and I want you to write down all 7 properties, and then use a pencil or a pen and go through and see if you can write in the answers to these 7. Then when I go through them, cross off and replace or fix what you wrote if it is incorrect. This way you know which ones you need to study and which ones you already know. Remember, the earlier you get these memorized, the happier you will be. So go ahead and pause your video and see how well you do with the practice. All right, coming back now, here we go. Log base b of 1 equals 0. Log base b of b is 1. Log base b of b to the a equals a. Log of b to the power of a is equal to a log b. B to the power of log base b of a is a. Log base b of uv is equal to log base b of u plus log base b of v. And with the division, log base b of the top, u, minus log base b of v, which is on the bottom. Those are your basic properties. All right, so we're going to now go on to do some practice. And the first problem type we're going to deal with is evaluating, which means get a number. All right, so here we go. Let's see, the first section of this we're going to do using your brain. So no calculator, just your brain. So here we go. We're going to do log of base 4 of 64. We're going to calculate that. Now, one of the easiest ways to attack evaluation problems are to go ahead and write in that this equals some mystery number x. This then helps your brain put it into exponent form, which is 4 to the power of x equals 64. In exponent form, if you can rewrite the right-hand side as a base 4 number, then you can get the answer. If you're not sure, you could try factorization. For example, 64 is 8 times 8. 8 is 222, and then we have 222. So if you're trying to figure out how many groups of 4 you have, you can group 2 2s, 2 2s, and 2 2s. I have 3 groups of 4. So 4 to the x is equal to 4 to the power of 3 because there's 3 groups of 4. So that's one way to figure it out. And then, of course, that would mean x is equal to 3. All right, let's do another one of these. Log base 2 of 0.125. Again, make that equal to x. Flip it into exponent form. So 2 to the power of x equals 0.125. And I find that decimals are less handy than other things. So if you remember that 0.125 is actually 125 thousandths, because it's in the 1,000ths place, that actually reduces to 1/8. So if I rewrite this as 2 to the x equals 1/8, then I can take and rewrite 1/8 as 2 to the negative 3, because 2 times 2 times 2 is 8, and then I need to flip it. So for this problem, x is negative 3. Let me circle those. There we go. All right, what about log base 1/4 of 256? Okay, again, write it equal to x. Flip it into exponent form. So 1/4 to the power of x equals 256. Now on this one, the 1/4 is kind of cumbersome because it has the number on the bottom. So what you might consider doing is rewriting 1/4 as 4 to the negative 1. So that gives you 4 to the negative x. And then 256 is actually 4, 4, 4, 4. 4 to the power of 4. So if negative x is 4, then x must be negative 4. All right, the last one we're going to do is log base 32 of 2, and we're going to evaluate that. So again, set it equal to x. Flip it into exponent form, so 32 to the power of x equals 2. Now in this case, 2 is to the power of 1, so I need to manipulate the left-hand side. 32 is actually 5 2's multiplied together. So if I replace the 32 with 2 to the power of 5 raised to the power of x, then I get 2 to the 5x equals 2 to the 1. So pulling the exponents off, now that the bases match, I can say 5x equals 1, so x must be 1/5. So sometimes you're going to manipulate the left, sometimes the right. Just depends on what you're trying to set equal. The goal is to have equivalent bases. A 2 and a 2, a 4 and a 4, a 2 and a 2, a 4 and a 4. Get the bases the same, and then put the exponents equal to each other. All right, so number 2, we're going to do calculator practice. And we're going to do the practice problem, log base 10 of 7. So if you look at your grapher, you have a log button here. It just says log, and that is automatically a base 10. So if you're trying to find log base 10 of 7, you just press log. It's already base 10. Press the 7, enter. And typically you go out like 5 places. You round back to 3, so you want to go out at least 4 places, 0.84509, and then you'll do what the directions tell you, but if it's round to 3 places, the 0 rounds the 5 to stay a 5, and we get 0.845. So that one was pretty simple, but now we're going to do one that doesn't have a standard base. So log base 2 of 5. In order to input this in your calculator, you need change of base formula. So this is equal to log 5 over log 2. And then we need to put that into our calculator. Now when you do log over log, make sure that you put parentheses around the top log and parentheses around the bottom. So left parentheses, log of 5, close the argument, and then a parentheses to close the top. So there's 2 parentheses around the argument and 2 around the entire log. Divided by left parentheses, log of 2, close the argument, close the bottom. So lots of parentheses in this. And that's 2.32192. Again, if we're rounding back to thousandths, 9 rounds the 1 up to 2, and we get 2.322 as our number. Now remember, if you do a log base E, there's actually a natural log button here, LN. That is automatically a base E, so you wouldn't have to use change of base if it's a base E, natural log. All right, so those are our evaluating problems. All right, let me flip the page here. Roman numeral 3. We're going to expand. Expand the expression. And the first example we're going to do is log base 4 of 36 cubed. Okay, so we have a property that says when the argument is raised to a power, the power can go to the front. So this is now 3 log base 4 of 36. You want this number to be as small as possible. Try to get it down to single digits. That's the goal of the worksheet. So 36 is 6 squared. So log base 4 of 6 squared. And then we can move the 2 out to the front, and it gets multiplied by the 3. So 6 log base 4 of 6. Now we're going to use our addition property for expansion. And the 6 is equal to 2 times 3. So we're going to expand that. So put the 6 on the outside. Log base 4 of 2 plus log base 4 of 3. And that would be your expanded form. So remember, when you're expanding, they want no parentheses, no exponents, no fractions, and the lowest possible argument. So basically, get as many terms out of it as you possibly can. All right, let's do another example of this. Example 2, we're going to expand log of 8xy to the 4th. Okay, so the nice thing about the log property for expansion is it works with 2 or 3 things being multiplied together. Since I have 3 things being multiplied together, I can expand it into log 8 plus log x plus log of y to the 4th. Now remember, lowest possible argument, no exponents. So we know that 8 is 2 cubed. So that 3 can go out in the front. And we've got 3 log base 2. Now log x is about as simplified as it's going to get, so just bring that down. And then for this exponent, it needs to float to the front of the log. So it's 4 log of y. And that is fully expanded. All right, Roman numeral 4, condensing. Condensing the expression. And your goal for this is you want it to have one term at the end with no scalars. All right, example. We're going to do 2 log base 8 of x minus log base 8 of 5 minus 3 log base 8 of y. Now, looking at all those negatives, you might be tempted to use the quotient property, but there's a problem. When you do the quotient property, you can only use 2 terms at a time. So it's not like the multiplication property where you can string it out into 3 pluses. Quotient can only use 2 at a time. So in fact, most of our properties, you can only use 2 at a time. So quotient property, you can only use 2 at a time. And it's the same for the product property. You have to have 2 terms. So what we have to do with this is break it into pairs of terms. And there's several ways to do this, but I think the easiest way is to separate these 2 out by dividing out the negative. Before I do that, though, I'm going to get rid of the scalars because there's no scalars when you condense. So this is log base 8 of x squared minus log base 8 of 5 minus log base 8 of y cubed. Okay, no scalars. Now I'm going to divide a negative out because I need a pair of terms to work with. So I'm going to divide a negative. That gives me log base 8 of 5 plus log base 8 of y cubed. This is now product property. I have 2 terms together, so I can combine them into log base 8 of 5y cubed. Let me just rewrite this one. So there we go. Now we have two terms to work with for quotient property, so I can stack these up. Remember though, when you stack them up, that the bases have to match. In all of these, the bases have to match. So they have to be all 8s or all 10s or all E's. If the bases don't match, you cannot condense. So for all condensing, the bases must match. Super important. And sometimes they get tricky. And if there are two different bases, then you'll have two terms at the end. One that you simplified for the one base, the other one where you simplified to the other base, and then they will stay separate. In this case, though, they are the same base, so I can use quotient property. So log base 8 of x squared over 5y cubed. And that is completely condensed. Now, as I'm thinking back, I seem to contradict myself. The difference between expanding and condensing. When you expand using the product property, you can expand three terms out. You can expand as many things as you have multiplied together. What you can't do is take three pluses in a row at one time. That's the rule. Are there times when it seems like you put three together? Yes. But the rule is only two terms at a time. So if you can figure out a way to do it two terms and two terms, you will know that you are perfectly correct, because that could be confusing. All right, let's do another condensing problem. So example 2, this one's a little shorter. Natural log x to the 5th minus 2 natural log of xy. Okay, so these are both natural log, which is good because it means they're both base E and we can put them together. When you put them together, though, you can't have scalars. So before you can do quotient property, you first must remove any scalars. And that goes for quotient property and product property. They don't work if this has a 2 and that doesn't have anything. Now here it wasn't an issue because I moved the 2 and I moved the 3 before I used either one of these properties. See, there's no scalars on this, so then I didn't have to worry about it. Same thing here. When we were expanding, there were no scalars to worry about when I did the expansion. So you must remove any scalars before you can condense. So we're going to move that 2. So natural log x to the 5th minus natural log of xy to the power of 2. Now I can use my quotient property. It's going to be natural log of x to the 5th over xy squared. Now you've got x's top and bottom. You need to take care of that by simplifying. So this is x to the 5th, and on the bottom, when I distribute the 2, it's an x squared y squared. I can eliminate 2 of the x's, and I get natural log of x cubed over y squared. So when you're stacking things with similar letters, make sure that you simplify. Any new fractions that you get have to be simplified. These will get better with practice. It's just a matter of doing lots of these problems in a row, and then suddenly the processes will start to hit your brain. Main important thing is to get your properties memorized. There are 7 of them for logs that you need to know. You should have these memorized cold. If they're not memorized, you won't think of them when you're trying to do your problems. All right, have a wonderful afternoon. Goodbye.